Hello student, myself Ritin Sahu. So today we are going to discuss about the block diagram of 8255 PPI. So in previous video, we have already discussed the diagram. So first 8255 is widely used programmable parallel input-output device. It can be programmed to transfer the data under various conditions from simple input output to interrupt input output. So it is flexible, versatile and economical. That is when multiple IO ports are required but somewhat complex. So it is an important general purpose IO device that can be used with almost any microprocessor. The 8255 has 24 input output pins that can be grouped primarily into 8 bits parallel ports A and B, with the remaining 8 bits as port C. The 8 bits of port C can be used as individual bits or be grouped into two 4 bits ports CU and CL, that is port C upper and port C lower. The functions of these ports are defined by writing a control word in the control registers. The internal architecture of 8255 consists of three sections. One is data bus buffer, second one is read or write control logic, and third one is group A and group B control. So, first one is data bus buffer. This three-state bidirectional 8-bit buffer is used to interface the 8255 to the system data bus. Data is transmitted or received by the buffer upon execution of input or output instructions by the CPU. So control words and status information are also transferred through the data bus buffer. So second is read or write and control logic. The function of this block is to manage all of the internal and external transfers of both data and control or status word. It accepts the input from the CPU address and the control buses, and in turn issues commands to both of the control groups, that is group A control and group B control. So next we will discuss about the two types of group A and group B control. The functional configuration of each port is programmed by the system software. In essence, the CPU outputs a control wire to the 8255. The control wire contains information such as mode, bit set, bit reset, etc. that initializes the functional configuration of the 8255. Each of the control blocks, that is group A and group B, accepts the commands from the read or write control logic, receives the control words from the internal data bus, and issues the proper commands to its associated ports. So next is ports A, B and C. The 8255 contains the three 8-bit ports, that is port A, port B and port C. All can be configured to a wide variety of functional characteristics by the system software, but each has its own special features or personality to further enhance the power and flexibility of the 8255. Port A, one 8-bit data output latch or buffer, and one 8-bit data input latch. Both pull off and pull down bus hold devices are present on port A. Next would be, so it is one 8-bit data input or output latch or buffer and one 8-bit data input buffer. Next, 4C, so one 8-bit data output latch or buffer and one 8-bit data input buffer. Here, no latch for input. So this port can be divided into two 4-bit ports under the mode control. So each 4-bit port contains a 4-bit latch and it can be used for the control signal output and starter signal inputs in conjunction with ports A and port B. Next, operating modes of 8255 PPI. So there are two different modes of 8255 PPI. These modes are bit set reset mode, that is BSR mode, and second one is input or output mode. So bit set or reset mode is used to set or reset the bits of the port C only. For BSR mode, always B7 will be 0. The control register is looking like this. The D3, D2, D1 will be 000 to 111. In this mode, it affects only one bit of port C at a time. When user set the bit, it remains set until user unset it. The user needs to load the bit pattern in the control register to change the bit. So next mode is input or output mode. This mode is selected when the D7 bit of the control register is 1, and this mode has also three different modes. These modes are mode 0, mode 1 and mode 2. So first, mode 0, that is simple or basic IO mode. In this mode, all of the ports A, B and C can be used as input or output mode. The outputs are latched, but inputs are not latched. This mode has interrupt handling capability. Next is mode 1, that is handshake or strobed IO. In this mode, the port A and port B can be used as input or output port. The ports C are used for handshaking. In this mode, the inputs and outputs are latched. This mode also has the interrupt handling capability and the signal control to match the speed of CPU and IO devices. So next is mode 2, that is bidirectional input output port. So in this mode, only port A can work and port B can either be in mode 0 or mode 1, and the port C are used for handshaking. So in this mode, the inputs and outputs are latched. The control register is looking like below in this mode. So first D7. So the D7 bit is 1 for IO mode and 0 for VSR mode. Next, the D6 and D5 bits are used to set the port A mode for 00. It is M0 mode for 01. It is M2 mode for 10 or 11, and D4 is 1 when port A is taking input and 0 when port A is sending output. Next, D3. So D3 bit is 1 when higher nibble of 4C is taking input, and it is 0 when higher nibble is sending output. Next, D2 bit. It tells the mode of port B for 0, and it is M0 mode for 1. So for 0 it is M0 mode, and for 1 it is M1 mode. Next is D1 bit. So D1 bit is 1 when port B is taking input, so and it is 0 when port B is sending output. Next is D0 bit. So D0 bit is 1 when lower nibble of 4C is taking input, and 0 when lower nibble is sending output. So these are the basic functions of the 8 bits of the control bar register of 8255 PPI. Next is pin diagram. Pin diagram of 8255 PPI. So here 40 pins are available in 8255 PPI. So P pin 1 is PA3, that is port A3. Pin number 2 is PA2, that is port A2. Pin number 3 is PA1, that is port A1. And pin number 4 is PA0, that is port A0. Pin number 5 is add bar, that is read bar. Pin number 6 is CS, that is chip selection. Pin number 7 is ground. Pin number 8 is VSS, that is power supply. Pin number 9 is A1. Pin number 10 is A0. Pin number 11 is PC7, that is port C7. And pin number 12 is PC6, that is port C6. Pin number 13 is PC5, that is port C5. Pin number 14 is PC4, that is port C4. Pin number 15 is PC0, that is port C0. Pin number 16 is PC2, that is port C2. Pin number 17 is PC3, that is port C3. Pin number 18 is PB0, that is port B0. Pin number 19 is PB1, that is port B1. Pin number 20 is PB2, that is port B2. Pin number 21 is PB3, that is port B3. Pin number 22 is PB4, that is port B4. Pin number 23 is PB5, that is port B5. Pin number 24 is PB6, that is port B6. Pin number 25 is PB7, that is port B7. Pin number 26 is VCC. Pin number 27 to 34 are D7 to D7, D0 to D7. That is the data are available D0 to D7. Then pin number 35 is reset. Pin number 36 is write bar. Pin number 37 is port A7. Pin number 38 is port A6. Pin number 39 is port A5. Pin number 40 is port A4. So that's all. Thank you.